So I'll be presenting here the recent developments in Australia on the use of FRP reinforcing bars for concrete structures. So what is the need? So why do we need to use composite reinforcing bars to our concrete structures? So this photo shows one of the high-rise building on the Gold Coast, which was built only after 20 years it was which was demolished only after 20 years it was built. And the reason for that is because of the significant corrosion of the steel reinforcement in its main structural components. And in fact, the repair and replacement cost associated with steel corrosion in Australia is estimated at around 13 billion per year. And in addition, the risk of corrosion is likely to increase due to the climate change. So due to the increase in level of carbon dioxide, temperature, as well as humidity, the corrosion of the risk of steel corrosion is very high, will be very high not only on the coastal regions but also the inland parts of Australia. And because of these issues, then many engineers or many asset owners are considering or looking for alternative reinforcement that will minimize the risk of corrosion in steel reinforcement. So what is the solution? So fiber reinforced polymer bars or FRP bars. So these bars are made of fibers and matrix. So the advantages of these reinforcing bars, they are impervious to chloride ion and chemical attack. They also have higher tensile strength than steel, but they weigh only 1/4 that of steel reinforcement. Other advantages of FRP bars, they are also transparent to magnetic fields and radio frequencies, and also they are electrically and thermally non-conductive. And similar to steel reinforcement, FRP bars are available in different bar diameters, and they can be bent in the factory in different shapes depending on the application. So the research that we are doing at the Center for Future Materials provide engineers a better understanding on how concrete structures reinforced with FRP bars behave under different loading conditions. So we have looked on the bond performance of FRP bars to concrete. We have also evaluated the behavior of beams and columns reinforced with FRP bars, and also the behavior of precast concrete elements reinforced with FRP bars. And the information or the data that we have obtained in these studies have been very useful in the establishment of design specification standards for this type of reinforcement. And the works that we have done at CFM, we have successfully implemented them in collaboration with Inconmat Australia, Postal Canada, University of Sherbrooke, University of Melbourne, and the Queensland Department of Transport and Main Roads. So some of the highlights of the work that we have done at CFM or USQ. So this graph compares the bond strength of FRP bars to that of steel reinforcement. So 23 megapascal is the bond strength of steel reinforcement. And as you can see here, FRP bars of the same diameter, it will exhibit almost the same, or in fact slightly higher bond strength to that of concrete. And why this result is important? Because this result tells us that FRP bars can bond sufficiently with concrete to provide total composite action. And the behavior of concrete beams reinforced with FRP bars also tells us or showed us that by effectively designing concrete beams reinforced with FRP reinforcement, we can achieve a higher strength concrete beams with using the same amount of reinforcement, but also we can achieve a pseudoductile failure behavior, which is important in structural engineering because this behavior provides a warning of impending failure of the structure. And also, by providing sufficient spiral reinforcement to our concrete columns, we can minimize the degree of concrete crushing to our concrete or column members. And also, similar to beams, we can achieve a pseudoductile failure behavior to our concrete columns. And again, this is very important because FRP bars is conceived to fail in a brittle manner. But again, if we can design them effectively, we can achieve a higher strength concrete elements, but also with a pseudoductile failure behavior. And FRP bars, they are also durable. So the result of a field study that were conducted, so here in this particular field study, or in-field study, concrete cores were extracted from the bridge that was built 11 years ago, and those concrete cores contained FRP bars. So those FRP bars in the concrete core were extracted, and evaluated their physical properties, chemical properties, and also the microstructure behavior. And similarly, those behavior or properties were compared to that of the properties of FRP bars that were not exposed to the concrete environment. And the results shows that the bars extracted from the bridge is very similar to the properties of the FRP bars that were not subjected to this environmental condition. And similarly, the microscopic observation shows that the interface between concrete and also the FRP bars, they are fully intact even after 11 years in service. So with these findings, then we can we're able to conclude that FRP bars, or there were no degradation observed in the FRP bars even after 11 years in service. And the durabilities that we have done also at USQ showed that FRP bars can retain more than 90% of its mechanical properties even after 100 years in service. So similarly, currently, USQ is one of the nominating organizations which are developing the design codes and specification for FRP bars in Australia. So some of the other nominating organizations which are helping USQ in developing the standards are Austroads, Composites Australia, Concrete Institute of Australia, and the University of Melbourne. And because of those research findings that we obtained at CFM, it increased the confidence of asset owners and engineers in specifying and using FRP bars in different concrete structures. So in this slide, this slide shows some of the applications of FRP bars. And in particular, FRP bars have been used in structures built in or close to seawater, also in structures with low electric conductivity, structures with exposed to soil with high moisture content, and for storage structures for corrosive liquid. So this particular figure shows the Anton Getty Windham in Western Australia, wherein FRP bars have been used as a main reinforcement to its precast planks. So FRP bars have been also used in the detector loop at the Gold Coast Light Rail project, and this because of the non-corrosive properties of FRP bars, but also because of its electric and magnetic neutrality. It has been also used as a reinforcement to the revetment concrete wall at the Moray Bridge. So in this particular application, the soil has high moisture content, which is causing significant corrosion to steel reinforcement. And also it has been used as a main reinforcement to a concrete water tank for storage of corrosive liquid. So other applications of FRP bars, it has been used as a main reinforcement for pile cages. Also as a reinforcement to the foundation in the annex extension of the Toowoomba City Hall refurbishment project. And obviously, in this particular application, FRP bars provide a significant advantage compared to steel reinforcement to eliminate corrosion in this particular East Wharf in the New South Wales. And FRP bars also provided significant impact or significant advantage in the redesign of the concrete ramp planks for the Queensland Department of Transport and Main Roads, wherein current design, in their existing design, they're using galvanized steel. But to minimize or eliminate the corrosion of the galvanized steel, they're placing the galvanized steel reinforcement at the middle or mid-depth of the boat ramp planks to minimize corrosion. But using FRP bars, because they are non-corrosive, we can place the reinforcement as close as possible to the concrete cover, thereby minimizing the amount of reinforcement because the effective depth is becoming higher or greater. So with this new design, then we're able to achieve a boat ramp plank with the same capacity but with minimum amount of FRP reinforcement, leading to a more effective design. So what are the opportunities? So where we can further apply FRP bars? So FRP bars, they are very applicable to applications wherein or to structures experiencing significant steel corrosion. So in tunneling and railway, wherein this type of structures present significant outlay for the government, then we need to consider using high durable material, high durable reinforcing material to minimize or eliminate maintenance or minimize maintenance and ensuring the 100 design life of this type of structures. And in tunnels and railways, so in railway tunnels, reinforcing bars are prone to corrosion because of the severe atmospheric condition. So for lines or for railway lines or tunnels wherein trains will be operated by diesel-powered engines, the amount of sulfur dioxide emissions of this type of train is significant, increasing the probability of corrosion problem. And similarly, for electrified railway systems, stray current corrosion is a significant issue, but by using FRP bars, this particular issue can be eliminated. And also in tunnels, the moisture or the level of moisture and seepage is very high, causing significant corrosion to steel reinforcement, leading to costly maintenance. So let's say if we're going to use FRP reinforcement to precast concrete tunnel lining, to concrete culverts, to ballastless trucks, and also for continuously reinforced concrete truck slabs. So if we're going to consider using FRP bars, then we can assure that the corrosion of steel reinforcement will be eliminated, and we can provide or we can develop a tunnel structure that we can ensure to have at least 100 years design life. So that's all, and thank you very much.